Hello everyone, welcome to my channel. In this video we are going to learn about the shortest seek time first scheduling algorithm. So in this disk scheduling algorithm, it selects the request with the minimum seek time from the current head position. That means it is going to select the particular request which is very near to the header. So it chooses the pending request close to the current head position. Okay, so it is going to select the particular location which is nearer to the current head position. Okay, that means it is going to reduce the seek time. So in the case of the first come first serve scheduling algorithm, so the read write head movements are very high, right? So that's why it is going to select the neighboring request which is close to the head position. Okay, so here this is the request queue and the number of requests for the hard disk. So here the header starts from the 53. Okay, so here initially the head is at the position 53. So of all the pending requests, 98, 183, 37, 122, 14, 124, 65 and 67. Okay, so the cylinder which is close to 53 is 65. So that's why the read write head will move from 53 to 65. Okay, so it will move from 53 to 65. Right, see 1 minute. So it will start from the 53 and then it will move to 65 here. Okay, so next, so the so which request is a neighbor to the 65? So that is the 67, right? So this is the neighboring cylinder to the 65. So that's why the read write head will move from 65 to 67. Okay, so from 67 the closest cylinder is 37. So that's why the header will move from 67 to 37, right? So if you want to check, you can check that one. 67 minus 37 is 30, but 98 minus 67 is having the more seek time compared to the 67 to 37. So that's why we are selecting this request. Okay, so similarly the head moves from 37, so the neighboring is 14, so it is going to service the request 14. Okay, so and then from 14 the neighboring request is, so there is no neighboring request to service, so that's why it will go to the again back to 98. Okay, so it is going to serve to the 98. Okay, so and then from 98 to, so 14 to 98 it will move. So and then the neighboring request to the 98 is 122, so it is going to serve the 122. So the read write head will move from 98 to 122, and the neighboring the neighboring cylinder to 122 is 124. So that's why read write head will move from 122 to 124. And then, so what is the neighboring request for the 124? 183, right? So it is going to 183 here, and the neighboring request to 183 is, so here it has finished all the request to service, right? So that's why it has reached the end of the disk services, right? So here, so we can see that so the read write head has traversed from 53 to 65, 67, 37, 14 and then finally to the 183. So the total head movements we have to count now. So how to calculate the total head movements? That is 53 minus 65, right? So here, so 53 minus 65 and then 65 to 67. right? 65 to 67 plus 67 to 37 and 37 to 14. So 67 to 37 and 37 to 14, and then 14 to 98. So plus 14 to 98. 14 to 98 plus 98 to 122 plus 122 to 124 plus 124 to 183. So 124 to 183, right? So in this order it is going to, the total head moments are there. So 53 minus 65 plus 65 to 67. Okay, so if you calculate this, you will get the total number of head movements in this algorithm. So that is 236 cylinders. So this is the total number of head movements in this disk scheduling algorithm. And if you want to find the average head movements, then so 236 by, so number of requests. So number of requests here are 8. Okay, so if you calculate this, we will get the answer. So 236 by 8 means 8 2s are 16. Okay, 76, 8 9 72. So the answer will be 29.5. So this is the average number of head movements in the shortest seek time first disk scheduling algorithm. And it can be seen that the head movement is much less in this algorithm compared to that of the first come first serve scheduling algorithm. So here the only disadvantage here is it may cause the starvation of some of the requests. If the requests keep arriving close to the current head position, then the request for the cylinder that are far away from the current head position may not be serviced at all. So which is the main drawback in the case of the shortest seek time first scheduling algorithm. So this is about the shortest seek time first disk scheduling algorithm, and thanks for watching my video. Thanks.